what in the world is a pressure stop? So what it's going to be is a small piece of aluminum. It's smaller than what really the print makes you believe. It's just made out of 1x2, solid, just a little bit longer than 1.5 inches. So the idea is that this piece, this is the top view. You're going to be placing this down, and it'll go into a slot on the mill table. You're going to bolt it down with the socket-head cap screw. It's going to go into a T slot. It'll be drawed tight by a T-nut. You're going to have these two little wings that come off of here, 1/4-20 screws that come in through here. The idea is that you can put a large part in, bolt it or set it down on the table, put some pressure up against these two ears or two wings with some 1/4-20 screws, and you're going to be able to pressurize or put some pressure against a part and have it mounted down on the table. So let's get started. I just drew this up a few minutes ago. I was trying to come up with a couple of last minute quick projects that we could finish up with. And so as we walk through this thing, we're going to just kind of work it out as we go. I will work out some of the dimensions as I go. A lot of times I've already got these the dimensions and stuff kind of already prefigured. Today I'm not going to. We're going to just kind of work it out as we go. One of the things that I want you to see today is that we're going to use a little bit different, or a couple of different styles of socket head cap screw. So what we have is our normal socket head cap screw, 1/2-13, but we also have a second option, that is the low head. And so I'll ask you to find maybe some information on both of these screws as we go, and we'll see which one's going to work out better for us today. The idea is that we can set this thing down, and so when we get done, it's about 7/8 of an inch tall, I believe. So it's going to be a little bit shorter than that sticking up. You only got about 5/8 of an inch sticking up. So you could put a part that was 1 inch, essentially set it down on the table, put some pressure from both sides on it, mill all the way across the top of the surface without having to move it or shift it. Now you really want to drill through or cut down beyond all the way through the part. That's going to go into the table. So it's not a perfect setup for everything, but it is a good setup for a lot of different things. So a lot of times you'd call this a toe clamp. And so toe clamp's a little bit more specific and just a little bit better in the way that it works. So we're going to call this a pressure stop, and we're going to work some of the details out as we go, and we should end up with a pretty good little project when we're done. Okay, let's get started. So what I've got is a 3/4 inch end mill, and I'm going to use it to go ahead and start milling my T-slot, and I'm going to also mill off this edge. So as I go across it, I'm going to do my conventional cutting up this side of it, and then I'm going to go straight into cutting out these two sections here. I have not edge found it, done anything to it. I do have my head square, and my vise, my head trammed in, and my vise is square. That's the only thing that I've done so far. My material that I'm working with today is 6061 aluminum. I've got a 3/4 inch high-speed steel end mill in the spindle right now. So I brought something along with me today that I've been talking about off and on for a while, and I'm not going to need it right now, but I will take a minute just so that you guys can see what it is. When I'm talking about my Quill Stop, that's one of the tools that we use often. And so what I have is a spring-loaded Quill Stop. And so imagine that I'm drilling. I wouldn't be drilling with this end mill, or normally wouldn't be drilling with it. So I need to set a stop. I can use this adjustable stop here, and it's great. It's nice. I've got a little jam nut that I can jam those two things down. So if I've got a lot of holes that I'm going to do, I can set that. It sets to a nice depth that I can work with, and it'll stop there every time. But what if I've got some variation that I've got to do? I've got to do just a couple holes at 2 inches, a couple holes at 1 inch. I can use this spring-loaded Quill Stop, comes in, stops it at 2 inches, and then maybe I need to move up to a 1 inch. And so then I set it there. And that was going to be our project today, but I wasn't able to get all the things that I needed to get it together. So, so we're going to go ahead and do this project today. Quill Stop will come in the future. So I'm going to mill this edge, just mill it square is all I'm going to do, just get it nice and straight. Now sometimes if I want to make a really nice clean cut across the part, I will come back and do a little climb cutting on it. I would not recommend that most of the time. So if you're going to just take a really shallow pass coming back across something, just want to get that really glossy surface finish, you can do a little bit of climb cutting on here. Always though, whenever you're climb cutting, you want to make sure that you are that you've got your table nice and snug. Have a little bit of resistance on that. You do not want that screw to take off on you. All right, so at this point I've got my edge done and I haven't taken anything off the top. I'm gonna come in here, I'm gonna go ahead and start milling off the two sides of this thing. And today what I'm gonna do is I'm not even gonna use an edge finder. So I wanna make sure that I can come over here. I don't wanna stop and take the time to do an edge finding operation, because when I flip this thing over, I'll do the rest of those types of setup. So I'm gonna actually use my end mill as the edge finder to get my center on. So I'm gonna lower down my table. I'm gonna come right up here, and I am just barely gonna touch this. As soon as I see a mark, there you go. So I just barely hit it. You can zero it out. And so what I need to do is I need to come up and make a cut across this edge, and so it's about 88 thousandths from the top edge. So I'm going to go ahead and go on up. I'm going to go up about 680. I'll leave myself just a little bit for a finish pass. Now I'm over to the top of the part right now. I'm not going to take anything off the top of the stock itself. So I'm going to come in just a little bit. I'm going to zero out my knee. And I know my stock, whenever I get finished with this part, it is going to be 687 thousandths tall. So my thickness of my stock apart from the T-slot is 625. So that means my T-slot's going to be 1/4 of an inch. Now what I'm going to do first thing is I'm going to take just a real shallow pass across this. And why I want to do that is I just want to make sure that I'm coming out in the right spot. I just want to make sure of my depth that I'm going across there. Because what I don't want to end up with is a T-slot that does not, or it's off center. So as you can see, it's not milling all the way across. That's because the bottom of my part, or the top of my part here, is not necessarily square, or it isn't square or flat. Just all we've been concerned about, we got the bottom set in here with some parallels just to make sure. So I take my scale and I am pretty good. I'm just a little bit under 700 thousandths, so 670, 675. Now, here I'm going to be able to go back and forth, which technically is a climb conventional setup, but I'm doing the bulk of my cutting on the bottom. So it's really move. So let's just first off take a quick measurement of our boss itself. All right, I am just barely oversized. I'm gonna come in, I'm gonna check my dimension over here. Get my table out of the way a little bit, so I can get a good measurement over here, as good as I can with a pair of calipers. Okay. All right, looks like this far side is really good. I'm gonna take just a couple thousandths off of this side. Now I'm gonna stay at depth, and I'm just gonna come over here, bring my spindle back. Now what I'm gonna do, remember about keeping our load on our screw, I'm gonna come back up to 6/8. And I know I've already cut that, but that cut had a little bit of tool pressure against it, so I'm going to take a free pass or just an air cut back across it, just to see how much tool pressure that it might have had on there that it left off. If I can just take a couple thou off of it, I'll probably find myself right where I need to be. Okay, 688. Now you can hear I'm right back at that same number of 688, but you can tell it's taking a little bit of material off. Now in a perfect world, I'll be able to stop, check this, have it right where I want it to be. $621. I can definitely handle 621. It's really about a thou undersize. I'm gonna go ahead and let that go on there. If it was any more than that, I'd probably stop and change it up, but I've given myself 2,000s on there. Really, as long as that thing is a little bit under 625, it should still sit down into the slot. Okay, so I've got this edge milled. I've got the boss milled here. So now I'm really ready to flip it over and start working off of some other sides. Now, at this point, I should need one more operation with this part, with this end mill. So as I flip it over, start doing some operations there, I need to do some fly cutting and some side milling. I've already got this in. I'm gonna go ahead and flip it over, do my side milling, then go ahead and bring my thickness in and start working off some of those other pieces. I like to try and get that fly cutter as centered up in the stock as possible. It can be off center, it's not going to make any difference for it. More just personal preference of the appearance is what I'm mostly concerned about. I used to work with a guy who said, if you can't make it right, make it pretty. So we're going to try and make it pretty and right as we go finish this job up. Okay, so on this one, I'm gonna go ahead and run my fly cutter back. I don't need to go all the way across it. A lot of times I'll go all the way across it, just if the part's a lot longer. Our part's pretty short now, it's really short. And so we wanna make sure that we're bringing this thing in to height. Should be just under an inch right now. Okay, so I am 998 right now, so I just took a couple thousandths off that top. So I want to bring it into 880, or really 875 is actually, I think, the nominal on that. So I'm just going to take a 50 pass. Sneak up on this thing. Go ahead and bring in another 50 pass. Should be able to come in, take a 20 pass, and bring it to size. Go ahead and stop it here. This way, if I need to make an adjustment, some type of change, I can. And just deburr this front edge here. Now the bottom of this is not, so the bottom of this boss area, which was our top originally, is not machined. It's not quite as flat as the other sections are. So and you can tell even as you take a measurement across it, because and I've got my quill stop there, so I've got those two holes in the right spot. I'll go down and then come back up to 1 inch. Okay, and then I want to travel over. Print says 940. Nominal was probably 937, but 940 is what the print says, so that's what we'll go with. And what I'm going to do there is I'm going to go ahead and just hit a mark, make sure that that looks correct, and I'm going to just take my calipers and just take verification on that just to make sure that I'm in the spot that I need to be. So 940 is where I'm supposed to be. Yep, 940, and then I should be 1 inch from the edge. Yeah, okay, looks good. All right. Okay, so I've got my holes spot drilled and ready to switch out to my drill and do my drilling and counterboring operations. Okay, so I wanted to stop and just take a quick in-action motion here on the counterbore and using the bi-stop. And so I've already drilled the counterbore on this one, but you saw the counterbore getting drilled in a time lapse, but and I time lapse that because we've done counterbores before, and you get the idea on that. You've got your through hole drilled, you've got your pilot here, your counterbore follows through with that pilot. But I wanted to show you how I set the Quill Stop on there so that I could get a really quick, good depth. What I did was come down to the top of my part. So imagine this counterbore is not in there. I brought this down to the top of my part. Stopped it there. And then I took something that I knew was 1/2 of an inch, because my counterbore depth on this one, I knew I wanted to be about 1/2 inch deep. And so what I did was I just stuck a 1/2 inch spot drill or center drill in there, brought it down, set my Quill Stop on there, and then that gave me my depth. And so as I come in, I hit to that Quill Stop, it gives me my depth, and then when I'm done, I can take it off, move it out of the way. I'm good to go for the rest of the time. All right, I'm gonna get ready to go over to the bandsaw, and what I've got is I went ahead and scribed myself out a couple of marks here. I'm gonna go ahead and cut those out with the bandsaw. When I come back, I'll stand it up and go ahead and take off my, or tap my 2 1/4 holes on the backside. Okay, I'm ready to make 2 holes on this, and what I've done is I went ahead and I've did my bandsaw cutting. I set my part back up, got it setting on some shorter parallels, and I've came in and I've done my edge finding off of this corner here. That matches the print. I've come up 380 thousandths over 300 thousandths. Here's what I'm going to do where I'm going to vary from the print just a little bit. I can do this because I made the print and I know it's going to be pretty beneficial for it. This would be something that if you were in the shop or in a classroom situation, you'd want to double check before you did this. I've got this 257 hole here, or 257 drill, and I'm going to go down into the hole just a little bit because I've got to travel pretty deep with my tap. So I need to make sure that I can get enough thread in here, because as it sits right now, I do not have enough thread to get all the way through. So I'm gonna make myself a counterbore as I go through here. And so I'm gonna pull my Quill Stop back in and use it on these and go ahead and just give myself a pretty nice little counterbore here. Okay, I'm gonna go ahead and take these last two, or take this last operation over these last two holes, and just want to tap these two holes, 1/4-20. And so I'm gonna get all of my stuff kind of set up here so that I can make some nice holes as I go. I wanna make sure that I don't go down super deep. So I'll let myself kind of run these down partially and then finish them up by hand. And part of the reason that is because I'm actually, it's a blind hole and I'm running into this bottom wall in there. So I want to make sure that I don't hit on anything. So I'm going to go down into the hole, take it back out, go over to our next hole location. Okay, so now all I have to do is finish tapping my holes. I'm gonna hand tap those holes down to depth, put my set screws in it, try it out, and make sure that it works. So just to give you a little bit of application on the part that we just made, here it is sitting here in action. I've got low head in there, socket head cap screw. It's got a T-nut down underneath here. What we have is two set screws that go into the ends here, and they push pressure up against these two winged areas, connected in the middle by this small little section. And so it's really hard to see the two set screws sticking out through there, but they're pushing up against this part. And so what I have is a parallel, and then the parallel is just toe clamped down or strapped down, just to hold this thing down. And then so I just stuck a piece of stock just to give you an idea of what it is that we're doing here. And so this way we can surface the entire surface of a part, where yes, you can still do that in a vise, but you don't always have a vise application. This part may be way bigger than what a vise might be. So say it was maybe 12 or 14 inches long, where a vise situation isn't going to be the same. You could do multiple vices and that would hold it in there good, but maybe the part's big, heavy, oblong, and you need to bolt it down to the table or clamp it down to the table. This is a really good alternative for doing that. You can make 10, 12. I think you can probably have about as many of these as you want. So let's just see what it looks like in action. So from here, I can release the pressure off of these two screws. I could take the part, flip it to another side, and maybe flip it 180 from this, deburring in between, continue to surface something down. And so that's just another clamping option that you have.